So let's work on question 18 from homework 2. Hopefully this is the one that I'm using, the thing that allows me to share. Oh, good. All right. So in this question, I'm asking you to find an 11 nucleotide sequence that you could use in the detection of any of these 3 strains of HPV. So, women, when they do their Papa Nicolau exam or pap smear, that's what the doctors are doing. Well, they look in the microscope to see if the shapes of the cells are changed. And the other thing they sometimes do is there HPV in the cells? And the way they do that is using something called PCR. And if all you want to know is, does this person have any of these strains that cause cervical cancer? Maybe they're not concerned which specific strain. They just want to know, do you have any of the ones that are the bad ones? Then we would want to find the sequence that is common to all of them. So you know that in here I'm trying to ask, same thing would be, what's the consensus sequence? So what do they have that is common? All right, so then you need to be able to align the sequences to find what they have in common. And the sequences that I wanted to align are these 3. So what you would do is you click on each of them, and then you grab the nucleotide sequence, and the nucleotide sequence is on the very bottom of the page. I'm going to do this, but every time I open a new tab, I have to share a different screen. But let me show you what the records look like, because this is also so useful. It's stuff that exists that you didn't know exists, but it's paid with your tax dollars. So that's kind of nice to see, the use of your money in a way that is beneficial and that you can, I don't know, it feels very, very palpable to me. Okay, so this is what the records look like in the NCBI I told you about. The NCBI is the American EBI. EBI is the European version, and it's websites that deal with bioinformatics information. So here there would be like the title of it, and every record is going to have some number, and we could go click to FASTA immediately, but I want to scroll down so that you can see. So there's a bunch of things like, who came up with that sequence, and a bunch of stuff. So, this one is pretty short. So on the very bottom, there would be the sequence. So I told you it has to be on FASTA, and I'm actually going to do something that is wrong on purpose. This time for real is on purpose, so that you see what happens if you don't do this right. So you have this sequence for this, that's the first link that I gave you. And then there are 2 other links. I'm going to align all of them in a way that it's not the FASTA, and then you're going to see what's wrong with that. But let me see if I just click the FASTA. Okay, then it gives you this format here. But let's say that I didn't know to click the FASTA, and I just grabbed this sequence here for one of them, and then I'll do another one for a second one. And 2 will be enough to illustrate why this thing wouldn't work. So I'm going to open 2 tabs. And actually, you guys tell me, what do I use for comparing that sequence against the other 2? And I'm looking for, what sequence do they have in common? What program am I going to run? Right, Cluster is a choice. I can run that one. And I'm going to run that because that's what you suggested. My inclination is often to just do muscle, because it muscles through this by doing many trees and then seeing which one is the best tree. But we can also do cluster and see if it comes up with a string of 11 nucleotides that are the same. So I'm going to go to my cluster window, and the problem that I'm going to start has nothing to do with using muscle or cluster, but has to do with not knowing the format that you need to use for the computer to understand your sequence. So there are a few problems. I could say, oh no, okay, my husband must be copying stuff, and our computers are linked. Huh. And then when I copy stuff here, it will be very confusing for his email, I think. Okay, there you go. So, okay, there is one problem here already, but I'm going to pretend like I don't know yet. So there will be two problems. First one is, okay, I entered my first sequence. Now I'm gonna go to the second tab, which you don't see what I'm doing, but I'm going to those NCBI tabs. And now I need to see which one. Now I don't know which one I already copied and pasted. Let me do again. So I need to do this systematically on which tabs I have open. Okay, so that's one. And now this one. Okay. So right now, this is not in FASTA format. And there will be a problem with this. But there is also another problem. Do you guys see another problem? I didn't draw a lot of attention to it before, but I wanted to see if you figure out that I need to change a setting here. Right, yeah, so Tatiana saw that. So this says, you are pasting protein, and then my computer is thinking, so A, T, Cs, and Gs are amino acid sequences too. Right now it's thinking that this is some very boring protein composed of just 4 different amino acids. But let's say that I didn't notice that. I'm like, sure, I'm in a hurry, I'm just gonna run this. Let's see if the computer realizes that it's not protein, because maybe the code, people wrote this code, wrote a line saying, if you only see A, T, Cs, and Gs, give the user a warning message. So one problem is that I should change this to DNA. I'm going to pretend I didn't see that and run it to see what happens. The other problem is these guys, these two sequences are not in FASTA format. And then you're going to see what the problem is with that. And then I go submit. I'm like, I don't care. And then it says a minimum of 2 sequences is required. So it actually didn't notice that it's not protein. But then you're like, hey, computer, I did enter 2 sequences. Don't you see? You know, this is a big number. Now starts back to 1. And then you could say, oh, I'm going to enter a bunch of spaces in between them, separate them more. Let's see if the computer understands now. Then submit. Ah, a minimum of 2 sequences required. I'm like, all right, you win. I realize now. Since I didn't put this in FASTA format, the computer thinks that this whole thing is only one sequence. And it's saying, you want me to compare this one sequence against what? And I'm like, okay, that's why the FASTA format is important. So I needed to do greater than, and then some sequence, and then greater than some other sequence. I could even not put anything. Actually, I'm going to leave this one blank. And then you will see that the computer gives it a name if I don't write anything. But the FASTA, remember, that's a big deal because you need to know it has to be in this format, otherwise the computer doesn't understand what you're trying to tell it. So it's a greater than sign, a descriptor that may or may not exist here, and then you don't see this, but there is a new line character here so that the computer knows that the sequence starts on the next line. I could even put spaces here. The computer still knows that this is the beginning of the sequence. So I'm going to run it just these two to show you what happens when one says some sequence, the other one doesn't have the descriptor. Computer will put some name there, and maybe it will complain that it's not protein. Let's see. So I'm doing the whatever is not the right way. just to show you, oh, we did not notice. It thinks it's aligning protein. And okay, there is a bunch of matches, mostly because I didn't put a third sequence. So it's easier for 2 things to agree than for 3 things to agree. So here, this is the first word of my description, and then this is the code the computer decided to give when I didn't give it a name. All right, so now let's do the way you should have done this. You're like, oh, finally, that's what I want. But I just wanted to show you why something comes out wrong. So let's go back to Crostal. That. And then what I will do, I'm going to share the screen of the records that the easiest way to do this so that you know. Okay, first I'm going to show you the homework question. So this is how you do this. You click on each of these 3, and then there will be the FASTA link. The easiest way is just click there, and then you copy that. So I'm going to do the same thing for each of these 3. So there's that one, which is opening it as another tab, that one, and that one. And then I'm going to click on, let me show you what I am clicking. So I'll go here where it says FASTA. And what I want to copy is this. Okay, so I want the greater than sign, the description, which, you know, it's already there, so I don't need to type anything. Why not copy it? And then the sequence. And I paste that on the cluster window. So I'm going to open it, and I'm going to do that for all 3. I'm going to share the cluster window so that you see what shows up. Okay, so that's the first one. Then, okay, I need to give it a new line character. Then I'm doing the same thing for the second record. I'm clicking at FASTA, and then I'm copying that. And then I'll do that for the last one. Okay, and then I'm going to, as I said, I'm going to show you how you should run it. Here I'm going to change it to DNA. Okay, then I run it. It's not doing dynamic programming. It's doing some modification of it. As you guys know, it's comparing each 2, figure out which 2 are most closely related. And then here they are. And as I said, fewer stars because now we are having 3 things agreeing. And I said, what's the 11 nucleotide stretch? So the way I find that is I do a command find if I'm on a Mac, or control, so command F or control F if you're on a PC, and just keep typing stars and seeing, you know, where do you find the string of, I said 11. I think the way I did that was, let's see the maximum number of stars in a row. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then if I was like, ooh, are there 12? And then I did 12, it says no 12. So here my 11, that's the biggest stretch where they agree exactly. And then in the exam it'll be like that. As I said, not so hard as the other one. So what you do is you copy that, because that's the string of 11 where they are exactly the same nucleotide. And if this was real life and you wanted to detect all 3 strains, and even though they don't agree here, for example, or here, you could actually order from a biotech company, like you could order this piece of DNA and this piece of DNA, even though they don't fully agree, but then you would be able to detect both of them. Hopefully this was fun to you. It's a real life application of how you use these bioinformatics tools. I did this a lot. My God, this is my favorite thing for my PhD. which was design PCR primers, so all the align things and then find where they agree. And I wanted to amplify strawberry DNA. Yeah, good. I'm glad. Glad it helped, Kendall.